Hi there, how are we doing? So let me switch to my intro screen. There we are. Welcome today. And today we're going to have a look at something a little bit different today. It's probably the height of, or the pinnacle of what we're expected to know as far as Python is concerned. So we'll get to it and we'll have a little look at everything and see how we cope with it. So again, today, do put in the comments if things aren't just gelling, or well, I'm not explaining it quite well enough. Just let me know in the comments. I'll try and rephrase some stuff and try and do it in a different way, because this concept is an important one, but not something that's going to make or break your kind of career in coding. But it's just a kind of nice bolt on to kind of get to understand. It's something called recursion, and we're going to have a look at it today. Hello as well, Mr. Nash. Thank you for making it on time. Excellent news. Glad to hear it. And hello, Go Bananas as well. Thank you for saying hello. So let's get cracking with this. And we used Python for the micro bit last week. And this week, if I scroll to it, we're going to be going back to Trinket this week. So again, a gentle reminder for those that are new. I always like my big text, or large text, I think it is that I call it, just to remind us so we can see it there, large text. So we will be going to this trinket.io/Python, but do remember, if I copy this and paste it on, as we do that now, that we can get all the information if you're new to the channel, digital.edu.je. So by typing in that code, or coding language now, that URL, you can get to the web address, and here we have Thinking as a Coder, and we've got all the links. We have the live link that we can click on to get to where you're looking at today, as well as all the learning materials. And I will be using this again today. So when we go to things like the Python code guide down here, when I click on that, that's going to take us to this Thinking as a Coder, and feel free, we'll be having a look. In fact, what I should really do is refresh that, because I've added recursion there at the bottom. You can see that this is a live document, and when you click on it and go to recursion, you'll see some of the stuff I'm going to talk about here. I've not actually finished this code. I'm going to edit it as I come to that. We've also got the microbit stuff that we were looking at last week, and we've also got the Trinket here. So if I click on Trinket again, it'll take us to the Python, and more importantly, Python 3 code here. If ever you do see some code, sometimes it has it. This has the last stuff we were working on, the Hangman game from a while ago. You can just always highlight everything. You can use Control or Command A if you're on a Mac, delete stuff and press play, and just reset yourself to wherever you are. So we have those different options available to us. So let's have a look at recursion. It's a weird kind of example. It's a unique example as well that we have a look at. And the kind of idea that we were looking at today was, there's a film called, the name of today's session, which is called Inception. And it's a film where it's a dream within a dream. And you may or may not have seen this film. And it's the idea that it's something within something within something else. And this is the idea of recursion, that we're going to write a piece of code, a function, and it's going to call itself within itself. It seems a bit weird. It's better when we see it on the screen. And again, this is just something that we can look at to save ourselves coding time, but again, is not essential to write good code. It's just something that is a shortcut as you get better of coding, because we're getting to a point now where we could write stuff and we're just looking to write it better, more succinct, more quickly. So let's have a look at what recursion is. And we're going to look at an example here, which is called factorial. And it's something in maths that's very important, but we're not really too bothered about that. It's more the concept of what we're doing. Now, factorial, and if we did 6 factorial as an example, is written as 6 with an exclamation mark. And what that means in maths is you go 6, and then you go times 5, times 4, times 3, times 2, times 1. So whatever number you pick, you just go down until you reach 1. That's as simple as it is. So when we're having a look here, and I want to do 10 factorial, and we write it like that. That's a short maths way of writing 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It seems a little bit pointless, but it has lots of important reasons for using it in mathematics, and is a much shorter way of writing stuff. So we're going to deal with this problem. How do you work out this? Because, you know, I could do something as simple as 2 factorial, and that's just 2 times 1, and that's easy, 2, right? 2 factorial is 2. 1 factorial is just 1, because it's nothing. So the kind of weird example with 1 factorial is that it is just 1. You can't go lower than that. We've already reached 1. And if I did something like 3 factorial, for example, then it is simply a case of 3 times 2 times 1, which is 6. But each time I'm doing these calculations, I'm doing different times, different number of loops. So it's difficult to write a loop in this reason, because I'm not sure how many times I might be counting down. Now, there are ways you can work it out, like 6, 1, 2, 3, 4, 5, 6. Actually, maybe we could write this as a loop. So let's try and give it a go. So what would this look like as a loop? And what we can do is we can write something, and we can say factorial, so the number we're starting with, factorial equals 6. So we've just dealt with 6. Okay, in fact, let's go nice and easy. Let's do 3. We know the answer is 6 here, and then that way we can test it out. So if we have the number of the number that we want is there, what we're going to say is, well, I've just shown you that there, haven't I? 3 times 2 times 1. It's going to happen 3 times, and it happens each time. If I was doing 6 factorial, it would happen 6 times. So we've looked and we've found a pattern. So we've stated that the factorial is going to be 3. So we're going to say for x, or for I in range 3. Now, I'm just going to remind us for this, we're going to then say, or print. So each of these times that I'm using the print for loop in Python, I'm going to use the print. I don't have to. I'm only showing us the print so we can see the kind of inner workings of what's going on with loops. So for I in range, or for I in range 3, we're going to say print x. Okay, so use my colon there, print x, and just grab that. I haven't done my, there we go. I haven't done my bracket around that. There we go. I was using, it was quite interesting really. I was using C++, another coding language, the other day, and it was quite interesting to see the differences. So we might look at other languages. We've been using Python, and we've been using different ideas, and what we find out is when you start using another code, you forget the syntax of the codes that you were just writing in. So again, here we got the x hasn't been identified. Oh, sorry, there we go. For I in range 3, print factorial. There we go. Got to use the right things because I use x all the time. And we just printed 33333, right? So we've got the idea that we're doing it. But what we want to do each time is we want to take factorial, and then we might say, well, let's take that and let's do, okay, print factorial and then factorial minus 1. And here we got 2, and we keep having the same one because it's not changing each time I do it. So we've got the issue of how would I deal with this? How do I keep knocking it off each time? So we've got our print factorial, but what I wanted to do was actually say the number's 3 here. For I in range 3, I want to knock one off each time. So print the factorial, but then do factorial minus 1. So I've printed the 3, and then I'm going to say, yeah, I want to minus 1 from it. So each time we do that now, we've got the 3, print factorial, which is 3, then factorial is factorial minus, or factorial equals, all over the shop today, factorial minus 1. So we need to state that I'm reassigning this value, and then I get my 3, 2, 1. Okay, now if I want to do what I was showing you there before, is I want to keep timesing each of these going on each time. So I want to keep timesing them and adding them, and it gets quite complicated quite fast. And we can just start to do the sum equals. So let's have a look at this. We can put sum at the top. Sum equals 0, something like that. And we can end up timesing things going forward. So, in fact, what we might end up doing here is looking at my calculation for this and saying, right, let's think it through. What do I want to do each time? I want to do 3 times 2 times 1, but I can't do that each time. I've got my 3 and my 2 and my 1. How do I keep doing this? Well, it's quite tricky. But each time, what I want to be doing is I want to be also doing sum equals factorial, so the 3, and then we want to be multiplying by the factorial minus 1. So let's have a look what that does. And while it's giving me my examples there, sorry, I left my code in there today, pressing that, it's adding the sum. So let's print that as we go. Print sum. And don't worry about this. I'm kind of deliberately showing you why it doesn't really work this way. And it's not liking it. Built-in function sum. I'm calling myself all the time. So we run into problems by doing it in this way, trying to do it iteratively, we call it. So let's get to the real kind of nitty-gritty of today's section, which is what is the point of what I'm talking about? So let's go in and have a look at this example. So what I really want to do is I want to define a function, which is define factorial. So I'm going to call something, and then I'm going to call this x. I'm not going to give it a value yet. Okay, I'm just saying there's going to be a number in there called x. And what I want to do is say something like if x equals, and I'm not saying if it equals 1, I'm saying if it's exactly 1, which is the double equal sign, then I've finished. Remember what we said about 1 factorial? It's just 1. So I'm going to return the value of 1. So that's taking consideration. If I don't have to do anything to the number, which only happens with the numbers 1, then that's it. That's the end. Else, we're going to keep knocking 1 off each time. So we're going to return a value, which is the number we started with, x, times factorial. And then I'm going to explain this with the x minus 1 again. Now, why this way is a bit better than what I'm doing now before is because this is going to keep doing this over and over again until it stops. So if I say that the number equals 6, so that's the number I'm going to start with. Or in fact, let's just do a nice easy one, 3. Then I'm going to print, and I'll do some sort of word, the factorial of, and then end that and say number, whatever that number is, so it's 6 at the moment, is, and then we do the factorial, all the calculations done together. So what we're saying now is we've not seen this way of looking before, that what we've said here is, you see where I say factorial with a number in here, which is here, exactly there. What I want you to use is any number that I say here. So really, when we said x and we didn't know what number it was, it's because we can replace it with anything that we want. And that can be quite useful later on. We can write things, I don't know what it is yet, but when I come to think of a number, like I do here, I'll want you to use that one. It means that we can keep changing things. And when I press play here, it's going to say the factorial of 3 is 6, which is the answer. Now, what did that do? Now, what that did, again, like I said, is quite important that we understand. So what it did was it said, and this is the key area here, what number did you start with? I started with 3. And then I was going to times it by 2 factorial. So what it's saying is, I wanted to know the answer of 3 factorial. And what I did immediately was take that 3 and then times it by exactly what you said before, but 1 less. And then do the same again. I want you to do 2 times 1 factorial. And if you get to 1, stop. So it's knocking itself down each time. So instead of having to write, and this is where we get to the kind of, I said it would be quite tricky, and I'll stop quite quickly on this. If we said this as an example, that is 6 factorial. What we start to notice on our problem solving is that is 5 factorial. So this number is the same as 6 times 5 factorial. And then when we knock it 1 down, 5 factorial, this bit here, is the same as 5 times 4 factorial, which is the same as 4 times 3 factorial, which is the same as 2 times 1 factorial, which is the same as 1. So what we've done each time is this looks the same as this, which looks the same as this, which looks the same as this, but each time it's just knocking 1 off. And I'm going to leave it there because recursion is a tricky topic. It's a topic that just shows you that we can write things much quicker, much more simply by using these kind of tools and spotting that things look the same but slightly different each time. So what we find weird here, and we don't normally do in coding, is we've called something factorial, but we've called it again inside itself. Okay, so if you don't get that, that's not too much of a problem. It's that we understand that there's something called factorial, and it's the same each time. That we understand that this can be solved better with recursion, and that we don't always have to use loops to do things because the loops can get quite complicated. So I'm going to leave it there. It can get quite tricky with this, but effectively this is good because it's less code. This is much less code than anything I could try and write as a normal program. But if I did something like the number 100 here, the problem that we have, and this is where the multiple choice quiz will come up if you do the exam for this, what you will find out is if I do 100, then I'm going to say that 100 factorial, and this is, I'm not going to write it all out because this is going to be really tricky, is the same as 100 times 99 factorial, which is the same as 99 times 98 factorial, which is the same as 98. We see what we're doing here. I'm not going to repeat loads of it, which is 97. Each time writing the same thing over and over again, but reducing each side by 1. That's all we need to see the pattern of. Now, this is going to take forever going down and down and down and down and down there. This will hold a lot of memory. So if you are doing these kind of time-saving tools, you have to be aware whether your computer can cope with it. That's really the understanding of today. Sometimes saving time can also be at the cost of your computer processing power. That's the takeaway from all of this. So don't worry if that last kind of 15 minutes was a little bit tricky to follow. The key takeaway is there's something called recursion or recursive code, and it can save you time, but can take up more memory of the computer. That's really the nitty-gritty of it. And why am I banging on about these things? Well, we've got to a point now where we're virtually at the end of the core of everything that we've been talking about. So if I come in and have a look at actually my drive, which has all this code in, let me show you where we've journeyed through. So if you've not been with us for the entire time for this, we've been following this thinking as a coder computing curriculum here. And if I zoom in on this, we can see that we've actually done not quite as far, we've actually done quite a lot of this. And we're now at that stage, now you're returning to school for the summer term, sorry about that, that we could start to think about some of you doing this exam towards the end of the summer. And we can go to the school. Yes, I've been dealing with Rocky a lot, so we'll go back. We'll see how many people are keen to do this. And we can have a look at everything we've been doing. So let's have a look at the topic titles. So what is computational thinking? What is Python? That was the first session where we just said it's about thinking differently. So when we're looking at this here, it's the idea that we now know that we can write things quicker, but sometimes at the cost of the computer processing power. That's thinking a little bit differently. Is it worth doing something a little bit faster or not? We've looked at the hardware and software requirements. In fact, we've not installed Python. We've been using Trinket. But feel free to try and install Python on your computer. But we've got the microbit Python editor, and we've got this. So we've been able to do Python quite simply. We've had the idea about how to think. We've looked at different ideas, how to do that. We've also looked at algorithms, which just means can we write code without having to write code? So here, when I was doing all this factorial stuff, I could have written this in pseudocode, which means it's not exactly like Python. It's just like language. And I could say, start with a number called X. It's just highlighting the with because that's a Python thing. And then you say, use that number, X, and times it by one less than X, and keep going. Well, one less than X. And then you can say, keep going until you reach 1. So in a weird way, that's kind of pseudocode where we're talking about, or algorithm, where we're just explaining what we've done in code, but just in kind of normalish language, like a kind of shorthand of what we're doing. So that's all you need to know. You know, what is pseudocode? Pseudocode is just writing things down in kind of more human language, but it won't work. We'll have to go to Python and write some actual code for it to work. But we know that if we're just starting out, rather than waste our time getting annoyed with all this stuff here and writing this, we could have just written it out as a kind of plan. That's it. So we've done that. We've looked at that. Then we looked at getting started with some very simple kind of mathematical calculations. We were doing things like x equals 45, y equals 67, and then we were doing print x times y, for example. And we were having that there, connecting server, and 3015. We've done a simple piece of code. We've written Python. Done. Box ticked for this area. Then we started doing more complicated variables. We started looking at kind of a hangman game. When we started looking at strings and patterns, we started looking at ifs and elses. We started looking at other data types like integer and string, for example. So I'm kind of reviewing this very, very quickly. There's more detail towards this. We've been looking at enhancing our code, making it better with functions and with shortcuts like you've just seen today. We've talked, like I said here, if or elses. We have talked about ands as well. And then putting them together in more complex functions we looked at with Create Your Own Adventure and a little bit of the other games that we've looked at here. Then we looked at loops, the for loop, which we had a look at just now. Libraries, we brought in the math library and the random library, to be more precise, when we were doing random number generations for our games as well. We've had a brief look at recursion there in 15. We are now effectively getting into testing. And we've kind of been testing as we've been going, to be honest. And then that's it, the training plan. So we've kind of really gone fast through the whole situation for this thinking as a coder material. The time now is to kind of go back through the videos for us to give you some quizzes that you can test yourselves through and just start playing around and getting more comfortable with the code. So it's an idea now, and I mentioned this before in one of the other sessions, of really trying to make some stuff yourself and play around. So I like using Google. I think having a Google account is a very useful thing to do. If you're under the age of 13, I think you still need to get your parental approval to get a Gmail account, but it's very useful having one. And if you have one, you're able to access Gemini, which is Gemini.google.com. You can do ChatGPT and other things that are available. And we can start to use artificial intelligence, I think personally, to help us code a little bit faster. So if I was writing here, let's test it out. I should never do things live, but I'm going to do things live. Write a recursive Python script or code, you could say that, for factorial numbers. And let's just see what it might do here and test it out. So you might not have got what we've done today. We've defined stuff. It's given me some extra definitions. I don't need the things in here. It's just explaining this part. So let's copy all of this and let's paste it into Python. I've never done this before. Press play, see if it gets it right. There you go. Enter a non-negative integer. A little bit complicated, but that just means a whole number which isn't negative. So let's do 6. We feel, or actually do 3. We did 3 before. We know the answer is 6. Press enter. The factorial of 3 is 6. Brilliant. So it's done it. So here was a bit of commenting inside. We don't necessarily need that. I could delete all of that if I wanted to and press play, and it would do exactly the same thing. Let's do 6 now and press enter. It's also given me a bit of an extra thing, which is if you give a value less than 0, in other words, a negative number, it's not right. You can't use it. And then it's done the whole recursive thing here, the number and the number minus 1. And we've also got this kind of more user experience part here. And it's given me some errors. And so great, I've got something here that I'm able to use straight away. Well, let's give Gemini another go. Let's get a little bit... I like to start new chats with artificial intelligence because it remembers as it goes, as we're about to see if it makes an error here. Make a very simple, it probably won't get this, but a very simple snake game in Python. So let's see how this does. I think it's going to use too many variables and things like that. And it's got import turtle, it's got import random. This doesn't look too bad, but look how much code we've got going on in here. I'm going to press copy. I'm going to come into Trinket. I might have to zoom out of this a bit because it's probably going to do something in this box. So I'm just going to zoom out a little bit. And if I press play, let's see if it does anything wrong. So here, it will tell me that there was something wrong in my game. Here's a simple snake game. I don't think I have the right library. Oh, there you go. Here's a simple snake game. I copied too much of the text. I actually copied the bit at the top, which has nothing to do with Python there. So that's probably one of my first issues. Let's press play again, and then it's going to line 91 where it says there's an issue, and it's saying that there's a game loop. I did wonder about this because Trinket isn't a perfect solution. It can't always play games on the side. It doesn't have lots of different examples. So what you might do is, in this example, this is how we use AI. We can go and we can copy this. And what I'm going to also do is change my prompt in a minute. And if you just paste the error in, it tries to identify the error for you. So even if you don't understand what it is, you can try and use artificial intelligence to do it. So there you go, you're right, there's the errors in the code. Move the snake head. So it's done it for me. Here's the corrected code. So AI is not perfect. It is the rest of the code in the loop. So I have to be careful. I'm going to say, show me the whole code. So what it's doing is saying just change these areas, but I can't be bothered with finding out where I want to change it. So I'm going to just copy and ask it to show me the whole thing again. So you have to treat AI almost like a naughty kid who won't do exactly what you tell it to do, but you have to keep pushing it. So let's copy all that again, paste it, press play, and see if we're any better now. We just keep putting these errors into this and then keep saying, right, what's the next one? Line 1, did I do the same thing I did before? I did. I copied the whole thing again, silly me. There we go. I did also just going to check that I'm just going to copy. There's a copy code button here, which I prefer to use. And then give that another go, because then I won't do that silly thing. It's still saying this isn't right on line 36. So I told you, it feels like it's a naughty kid. So you keep going in and you keep copying the errors and you keep pushing it and you keep pushing it and you keep pushing it the entire time. Sometimes it just will never get it right. And I'll try a simpler game after this. And let's see if it can work that out. I'm glad to provide you with corrected code again. So we keep going. And this is where your show the whole code. Doesn't like to do it. This is where you see that this is what your teachers are kind of telling you. Artificial intelligence isn't that intelligent. It doesn't always do what you say it wants to do. It tries to please you and doesn't always get it right. And you have to keep pushing it. So right now I'm getting to a point where has it really saved me any time? And look, it just keeps coming off and it won't do it. So let's try something easier. Snake game's quite hard. What you can say is make a simple, as we've done here, hangman game in Python. The thing that Trinket struggles with is game-based scenarios. It doesn't mind word-based ones. So here's one here. Copy the code. I've got more faith that it will get this one right. Gemini has not been creating images at the moment. There you go. So I'll explain that in a moment, Mr. Nash, because that is an excellent question. Because here we've got the hangman game. The word is there. Guess what the letter is? Let's try A. The A is in the word. B. No, I've drawn the hangman in here. R. No R. Oh, yeah, there is an R. A tr. Maybe it's a tr. No. Maybe T is not in the word. Maybe it's a tr. No. What might I do? W. I'm not doing well here. I'm going to run out of stuff in a minute. And what I do know is I can just cheat and go in here because it's got a list of nested words in here. There it is. It was going for, was it strawberry? No, I didn't have any of those. Grapefruit. There you go. Oh, G there. Oh no, it's got some extra words in here. So I'm going through and it's getting the game right. Now it's made it, and you can go through and you can edit this going through. Now you'll see here that I used text-based kind of graphics. I use as dash, and there's loads of ways that you can do this. Gemini, well, let's give it a go. Go into chat. We have this upload image, and if I ask it to make an image of a robot, it will come in here and it will say, it will just give me an actual image. It won't create one. So it's going to go to the internet. It's going to find some images. Although here, this one has. Maybe there's been an update since the last time. I was doing this. Wow. Make a picture of a teacher. Now, what it doesn't sometimes like is human beings. So when we're doing this, it will say, it sometimes gets worried that there you go. We're working on Gemini's ability to improve images of people, but they're not doing it right now. And there's a reason I'll explain for that. But if you're not doing images of people, these images have never been created before. They're yours. You can download them and you can use them. That's exactly what AI has been told. These images exist nowhere in the world. They've been trained on lots of images around the world, but they don't have them. So you could end up saying, make a sprite. Let's see if it gets that word. And a sprite is a way we just describe games, game sprites, game graphics of a Pac-Man-like character. And we can start to create our images. It's not perfect. It sometimes takes you a long time to get there, but it's not graphic-y enough. Make it pixelated for a game. Let's see if we can do that. So you have to be very specific about what you're doing. So when you've got the code for maybe your snake, if you're able to push that, there we go. That's a bit better, but it's more like a photo. That one's a bit better. But it really is just making those images. So it's not quite there yet. And the reason it did that is because a little while ago, and this is a very common thing, if you search for a successful person, or business person, and it's got images of different people, and you can have a look at different images all over. Quite often, the internet is biased in the fact that historically, the only people that have been suggested are kind of middle-aged men. Okay, and you get a lot of that in these pictures. People are trying harder to show, and much more successful women around as well, people of color, all sorts of things. But the internet is currently biased. So Google or Gemini, founding fathers, was asked a long time ago, or say a long time ago, a few months now, problem, where it was asked to generate some founding fathers, and it said that there were men and women and lots of diverse people in it, and that just simply wasn't the case. History can't change. So Google was trying to deal with the issue of bias by saying, yes, we know there are lots of kind of white men on the internet. We want you to actually show diverse range of people. And it's not been getting it right or wrong. So while they're working that out, images on the internet, people are finding it a struggle to do. So if you're not asking it to do pictures of people, it will try very hard. So I could try and let's do a new prompt, because it's gone down a bit of a rabbit hole. So I often do a new chat when it's gone down a bit of a kind of avenue and I don't want it to come out of it. Make a series of characters I can use for a computer game in 2D. So I'm trying to get it not to do 3D dimensional kind of photos or images. Here are character ideas. Create the images for these. So it was just trying to describe some to me. I said, no, that's not what I wanted you to do. So again, it's being like a problem person in the class that's not doing what I wanted it to do. So you have to keep going. We're working to improve it. It's not liking it because I said characters. So if I do in Pac-Man style, create sprites for a game in 2D. So again, it's not always saving us time by doing this. And again, here, it's just not wanting to do it. So there are things that you can do, like you can go to ChatGPT, you can create an account for them. And again, you have to be of a certain age, so do make sure you have people's permission and everything like that. I have a ChatGPT account. It's just a different version. Google and Gemini is one. This is there. I've got image generator, logo generator. So let's go to image generator and say, make a series of characters or pixel characters for a game in 2D. There we go. So let's see if that does any better. Now, ironically, even though we've seemed to have gone down, we started to talk about quite a complex recursive Python code. This method of dealing with AI is exactly as we were talking in the very first session about thinking like a coder, about thinking differently, a little bit more outside the box. If something doesn't work, go for another one. So creating a series of 2D games sounds like a fun project. It's giving me that. I'm just saying, yeah, go for it. Once I have the information I create. I've not given it enough information here to talk to. It's saying, what's the theme of the game? So let's do this. It already knows I want characters, so I'm going to just paste in here theme or setting, futuristic spelled correctly would really help. There you go, come on then. Oh, futuristic. Okay, character roles, playing the game hero, one hero, one boss, and 3 non-playing characters, NPCs. Art style, pixel art, such as 8-bit pixel art. Pixel art style, 8-bit, not 16, just means even more graphic. Color palettes, purples and greens. So we're being really specific on this now. It's remembered that I want to do everything else before, hopefully. We call this in context. Great, there we go. Great, here's a plan for doing it. I don't want the plan, I want the image. You're an image generator. So I'm now going to say, right, do the images. Perfect. This all looks good. A scientist, mechanic, guard. Would you like to proceed? Yep, love your ideas. But you can tweak them now. You could say, no, actually, you've gone down the wrong road. I want it to look like this or the other. And he's going to start by doing it. So it's like having an assistant. It's not a good assistant. It's a bit of a rubbish assistant in how it understands the rules that you're giving it. But it is a very good one at creating things. So there you go. I can proceed to give you generative visual or something you carry a specified pixel ID. Is any way, let me know. It says, I can proceed to generate visual representations. Generate the images. Yes, I do want to know. Generate the images. So it's being really kind of problematic. There we go. We've gone down this rabbit hole, and right at the end, it's not done it, and I know it can. So this is what we talk about with the rabbit holes for this. So I'm going to go back and go through it and say, do you know what? You were rubbish there, ChatGPT. I'm going to come out and create something brand new. I'm just going to go for one. It can't deal with lots, by the way. Create a pixel art image of an 8-bit hero for a game I'm making. I'm making for a dungeon escape game. Okay, let's see if it likes that a little bit better. It doesn't like too few instructions, it keeps going. So this is exactly what we're talking about. You don't get frustrated with a problem, whether it's Python or whether it's asking AI to do something it doesn't seem to want to do. You have to keep persevering, keep bashing down that door, and keep going for it. And then hopefully we're going to end today's session by having a go at that. So the challenge is, if we're looking at today, to go back through the videos that we've looked at. There we go. Finally, I've got my hero here that I can download and use. I'm just going to push it a little bit further. Can you give me a series of images to help it animate a running character? It might do that. So I kind of want the movements of this going through. Let's see if it will do that. Here's the breakdown of where it's just giving me the instructions again. I'm going to have to do it one by one. It says I want a starting position, a mid position. I'll see if it will do it after that. So go to Think as a Coder, go to the live link, you've got the live link here for everything. And we've got all of the videos that we've had so far, this is the 9th one. Go through them, have a play, remind yourself of all the pieces. I will then come through and start to make some quizzes for us. And I think the 10th version of this will be showing you how to prepare for a potential online exam if you want to. And then I'll continue with maybe game making. People can maybe do some suggestions. If people are liking the idea, one of the great Python examples is Pygame. And you can use Pygame and go to pygame.org and have a little look. No, I don't want the news, I just want Pygame. May send me to the news each time, getting started, and having a look about how you can download the projects for here, all the documentation, all the developments. We can start doing Pygame examples if people want to go down that route. If people just want to go down the robotics route, I can do that. Love building robotics. Have a look at YouTube to look at Pygame projects. They can be really, really good. So a Pygame project that we have here, for example, once the adverts have got out of the way here, is having a little look at things like this. You know, these types of games have been made with Pygame. Exceptional, right? You can make some really good kind of games with this, platforms, kind of thrilling games. You can have roguelikes, all the types of different games that you can make. Very Dead Cells type games coming through there, and even some three-dimensional ones that are harder. So there's lots of different types of things that we can do. It's where we want to go after this. So to do that, though, we need more of a fundamental understanding, so going back and revising as such. Then we can take it further and do that exam, and then we'll be done. And then you've got a qualification. And like I said, we can continue this going forward with different projects. I think the kind of 10-week limit is quite good. I think it's good to then stop and do something else. So we'll make next week the last kind of online version of this, thinking as a coder, before we have a look at maybe some other different types of projects. So do put in the comment whether you'd prefer to do some kind of gaming stuff or some more microbit robotic stuff, or if there's anything else that you want to see with the code. Because I think you've got a fundamental understanding now. You've seen that you can play with things like AI to try and give you some initial ideas for programs, put the error codes in to try and help it out, and keep going forward. So we'll wrap it up next week. Can't wait to see you for that, and we'll talk more about what it is. But feel free again, like I said, in the chat to put down what areas of Python you want to see us grow to, and I will come back to the schools, and if you want to do a qualification, we can get that sorted too. So thank you very much for your interest. It's been great going through a real kind of fast track, zero to hero Python examples, but we will keep going. But do go through those revisions, and just keep chugging along with Python and trying more and more. It's like any language. If you leave it alone for too long, it's very hard to pick up again. If you keep just chipping away at it with little ideas, you will go fast very, very quickly. Okay, so thank you very much again for listening. We will see you next week for the last of this series before we discuss the new one going forward. So bye for now. Thanks for watching.